in the year 1988, the first MSc biotechnology program was started in few universities like Banaras Hindu University, then Tamil Nadu Agricultural University, then Assam Agricultural Universities. Like this, few agricultural universities and general universities, these programs were started by the help of the Department of Biotechnology, Government of India. So at that time, this new department was created because on basis of the urgency of the research and development, Government of India started a new department, a Department of Biotechnology, around 1985 to 90. And on the support of this Department of Biotechnology, Government of India, 7 universities started this program on agricultural biotechnology, general biotechnology, marine biotechnology, and medical biotechnology. So the biotechnology courses started a few decades ago and appeared to provide a better alternative to young students for their career options. The application of biotechnology are vast as it caters to various agricultural, animal husbandry, fishery, health, pharmaceutical, industrial sectors, and marine biology. And biotechnology includes diverse subjects apart from biology, making it interdisciplinary, along with the technical part and engineering part. Application of biotechnology is giving rise to various new fields with various job opportunities. So before going to about the career opportunities in biotechnology, I want to clear the students what is biotechnology. So it is as the name suggests, biotechnology is a combination of science and biology and technology. It is an interdisciplinary subject, the marriage between the science, biology, and technology. Biotechnology uses biological systems. As the name suggests, the biotechnology, bio means life. So it utilizes the biological systems of the living organisms or their parts to make technological advances in the welfare of the society. In this, biological constituents like systems or organisms are used to make or modify or manipulate living organisms to develop new products useful to the mankind. Just as your best example is your BT cotton, your genetically engineered insulin, like this, or recombinant vaccines. So in coronavirus stage, many mRNA vaccines are there. These are the products of biotechnology. The biotechnology can be defined as an assortment of tools employed by scientists to recognize and manipulate the genetic makeup of the living organisms for applications benefiting the productions and possessing the agricultural products by developing high-yielding, nutrition-rich, biotic, abiotic resistance plants, new products like insulin, vaccines, or genetically modified microorganisms to clean our environment. And for this, different tools are used in the biotechnology, like genetic engineering, gene editing, in vitro mutations, site-directed mutations, then proteomics, transcriptomics, genomics, tissue culture technology, animal and plant tissue culture technology, marker-assisted breeding, immunodiagnostics, and sequencing technology. These are the different tools are used to manipulate the living organisms or part of it to make new product or to modify the plant or animals for the betterment of the society. The objective is to how the society will be benefited by this technology. Then before going to the career technology, we shall see what are the scope of taking degree, obtaining a degree in biotechnology. So the biotechnology is offered in graduation level as well as post-graduation level, PhD level. So any student with biology, chemistry, physics, or mathematics in their class 12 can take up biotechnology as their specialization in their undergraduate course. Similarly, agriculture students, veterinary students, and engineering students can also take up. The undergraduate program in biotechnology is of two types. One is BSc Biotechnology, another is BTech or BE Biotechnology. So BSc Biotechnology is 3 years durations, whereas BTech Biotechnology is 4-year durations. After completion of graduation's degree in BSc Biotechnology or BTech Biotechnology, one can opt for MSc Biotechnology or MTech Biotechnology, respectively. In addition, other graduate students of zoology, life science, botany, veterinary science, agriculture science can opt the master of MSc degree in biotechnology or MTech degree in biology. So the government of India has started biotechnology programs in various universities, and this biotechnology program has been divided into different sectors. Agriculture biotechnology. So those completed the graduates of agriculture, horticulture, sericulture, they are eligible to read agriculture biotechnology. Similarly, general biotechnology. So any graduate of life science, botany, zoology, they are eligible to take MSc biotechnology program. Similarly, veterinary graduates can take MSc veterinary biotechnology programs, and BTech students also take BTech, MTech biotechnology programs. So, and in this way, the biotechnology programs are started in India, and after MSc programs or MTech programs, the students can go for jobs or they can go for higher studies like PhD degree in biotechnology, or after PhD they can go for postdoc. So most of the universities, colleges, IITs, NITs, and national institutes are offering BSc biotechnology, B or BTech biotechnology, MSc or MTech biotechnology, respectively. Most of in all states, in all universities, they have started the biotechnology program in both undergraduate and graduate level. So in this way, the students who are now they can choice, they can take options on different aspects of biotechnology to read in futures. So next is we shall see what is the career opportunity. The important is the students and their parents. They are very much worried about the careers. If there is no career, even though subject is very good, the attraction of the students to that subject is poor. So, and many times the students cannot able to know what is the career opportunities in biotechnology. So now we shall discuss about what are the careers the students can avail in future after completing their graduations and post-graduation degrees. So domain on which a trained biotechnologist can work is vast. As there are several disciplines involved in biotechnology, there is a great demand for experts in various sectors like industrial sectors, environmental sectors, medical sector, food manufacturing sectors, pharmaceutical sectors, healthcare sectors, agriculture, food sectors, animal husbandry sectors, fishery sectors. So in all these sectors, our biotechnology students are eligible, and they have already proved their excellent work in these sectors. Owing to this diverse profile, it can have widespread applications across multiple disciplines associated with bioproducts, food, nutrition, textiles, chemical, environment, animal science, agriculture, and many more, with a promise of offering ample opportunities to the aspirants in the upcoming future. Across the world, numbers are reflecting on increasing trend for the students of biotechnology. So biotechnology applications are used widely in the following industries. First, we shall see pharmaceutical industry, health. You see, in the first product of biotechnology is your insulin. So as you know, previously before 1983, the insulin is extracted from the bovine or from the horse. From their pancreas, the the insulin is extracted and they are used for treatment of diabetes patient. But that insulin is very costly, and also it has some side effects. Due to the application of biotechnology and genetic engineering, the genetically the insulin is nowadays the insulin gene of the human being is cloned in yeast and successfully cloned, and by growing the yeast in a bioreactor, now the yeast is human insulin is produced in a large quantity, and that is why the cost of the insulin is very poor, very less, and any patient, any poor patient can now affordable to use insulins. Before 1983, it was very costly. Only this biotechnology technique helped the production of insulin, human insulin, by cloning the gene of human in the yeast. This is the first example of insulin. Similarly, the vaccines, the recombinant vaccines are produced. For example, nowadays for corona treatment, most of the vaccines are different types. One is attenuated vaccines, another is heat kill vaccines, another is recombinant vaccines, mRNA vaccines. And these mRNA vaccines and heat kill mRNA vaccines and recombinant vaccines are prepared by utilizing the biotechnology tools, genetic engineering tools. So different Moderna virus, they are using the mRNA vaccines. So that is the one product, and that way we can able to control the corona. Then molecular diagnostic kit. You see, the nowadays the PCR technology, for coronavirus testing, the PCR, RT-PCR is used. That is the product of biotechnology, and also some enzymatic based kits are available, and this kit is the cost is less, and it can under less time we can diagnose the disease, corona disease. Not only the corona disease, many kits are available. ELISA based kits and DNA based kits are available for diagnosis of different diseases, from malaria to dengue, and even the pregnancy test. So in this way, biotechnology helped the societies. The many medicines have been developed, and nowadays molecular medicines have been developed to cure the patient. And for cancer treatment, so immunological linked vaccines are available, which will selectively attack the cancer cells, so that it will not affect the human body. So in this way, in the field of medicine and healthcare, the biotechnology has a large applications, and the people has already benefited by this technology. The second is agriculture. In agriculture nowadays, you see millions of banana tissue culture generated banana plants have been produced in all the states, and the farmers are utilizing this. Why? As you know, for virus, there is no control measures like coronavirus. Only is either you have to, in case of animals, human beings, you have to take vaccines, but in case of plant, you have to use disease-free plantlets. And the plant tissue culture technique is the only method by which virus-free, disease-free plantlets can be produced. So that in case of banana, there is a Bonchita virus disease there. There is no control measures. So millions of plantlets nowadays produced through banana in a short period of time, in a season-independent manner, from a single tissue, and the plantlets produced are uniform, homogeneous, and true. Main important is disease-free and true to the type. That is why the farmers are nowadays interested for planting banana plantlets developed through in vitro culture or tissue culture or micropropagation techniques. So second example is your BT cotton. You know, BT cotton, Bacillus thuringiensis cotton, that is the most successful example of product of biotechnology. By this BT cotton, we can able to control the insects. In case of insect attack, even in the cotton, the insecticides application cannot able to control the disease, and there is a devastation in the cotton industry. To overcome this, BT cotton was developed, in which a gene from the bacteria, the endotoxin gene in the bacteria, is cloned in the cotton plant, and a new variety was developed. And this varieties produce some toxins which is specifically toxic to the insect, but it is not toxic to the human being. It is not toxic to the animals, because the delta endotoxin is toxic to the insect because their gut pH is alkaline. Our pH is acidic, and that is why it is safe to the human beings. The other examples of in agriculture is golden rice, which is rich in irons and vitamins, and nowadays other rices were zinc fortified rice has been developed. So then we shall see animal husbandry. In animal husbandry, diagnostic kits, vaccines, cloning of in vitro fertilizations technology is used to produce better animals. So genetic engineering herbicide resistant plants, Roundup ready plants have been developed. For environmental conservation, biotechnology has a role. So the first genetically modified microorganisms have been developed, which can clean the oil in the sea. That's the first examples. Different genetically modified organisms have been developed, which can clean the oil, which can degrade the oil. Similarly, fishery, textile industries, cosmetics, and in every field, the biotechnology has applications. Engineering for production of enzymes, renin, the production of papain, different enzymes are produced, subtiligin, different enzymes are now produced, which is the genetically engineered enzymes like subtiligin, lipase. They are used in our washing powder for better cleaning. They are the product of biotechnology. So in this way, biotechnology helps the society, as the biotechnology has a vast applications, as the students are attracting to these subjects. And if a student has very keen interest and will do well, and in the future he will do very well in this field as compared to other fields. So now we shall see, after getting the degree in biotechnology, what are the positions a biotechnology students will get. A biotechnology student after MSc or MTech degree is eligible for getting any research associate in any research organizations, or lectureship or professors in different colleges and universities, sales managers, quality analysts, plant bidders in different government and private sectors, environment specialists, medical scientists or technicians, biochemistry and biophysicists, biomedical engineers, microbiologists, epidemiologists, and process and development scientists, biomanufacturing scientists or specialists, bioproduction operators. So these are the different posts for which our biotechnology postgraduate students are eligible. If you do well, there is a lot of scopes, lot of opportunities for you. So the different organizations where biotechnology students are finding their jobs are research organizations like you see DST, CSIR, ICR, universities or college and academic institutes, biotechnological companies, pharmaceutical and chemical companies, agriculture and crop production companies, food and beverage companies, hospitals, and other medical organizations. These are the organizations, industries, institutes, universities where the biotechnology students are eligible for their placements. So, and these opportunities can be divided into four. One is academic institutions and research organizations, another is industries, another is government sectors. First, we see the academic institutions where the biotech students are got employment. The important are Indian National Biotechnology Board, Department of Science and Technology, DST, and the Scientific and Industrial Research, CSIR. And CSIR has many research institutes. In Odisha, our Institute of Mineral technology. IMMT is there. So many research institutes are there. Then ICMR, Indian Council of Medical Research. In Bhubaneswar, there is a regional medical institute is there, where Dr. Sangamitra Madam is there, who helped the Odisha government for curbing the coronavirus, for testing and this. So then Department of Atomic Energy, Indian Council of Agricultural Research, ICAR, Indian Council of Agricultural Research, ICAR. ICAR has more than 10 institutes in Odisha, like your National Rice Research Institute, that is NRRI, previously known as CRRI, Dhana Gaveshana Kendra. This is the biggest rice research institute in Asia, where many biotechnology posts are there, and the students are nowadays working. Like other water management technology center, women in agriculture. Like so many ICAR institutes are there. Around 10 ICAR institutes are there in Odisha, and in all states, minimum 3-4 important ICAR institutes are there. And in these ICAR institutes, they're conducting one examinations, India Agricultural Research Service, ARS, and the students, after getting post-graduations, they will appear this ARS, and according to their merit, they will be posted in different organizations under ICR, Indian Council of Agricultural Research, in each state and union territories. Then Department of Atomic Energy, they are also posted there. Then Defense, DRDO. DRDO has also biotechnology students are there. They are engaged in how to produce the vegetables in glaciers. Similarly, many things. Indian Institute of Science, even ISRO, ISRO, some scientists are there. The Biotechnology Consortium of India, BCL, Indian, then DRDO, and state and central universities. And Institute of Life Science, that is under DBT. So these are the research institutes where the biotechnology students can work and get their career, and they will do better in these organizations, and they can flourish, they can help the society, the India as a whole. Similarly, there are some industries are there, big industries are there where the biotechnology students are working. These industries are Biocon, where Majumdar Madam is there as CEO, Panacea Biotech, Serum Institute of India. Now they are producing Covishield and supplying throughout the world. Serum Institute of India, Myco, Monsanto Biotech. They have developed BT cotton in collaboration with Monsanto, BT cotton, BT brinjal, but only BT cotton is allowed to cultivate. Novartis, Indian Immunologicals, Venkateswara Hatcheries, Ranbaxy, Dr. Reddy's Lab. They are also producing vaccines. Then Advantis, Indian Immunologicals, and Jain Irrigations, Seal Biotech, Reddy's Lab, many more. These are the industries where the biotech students are engaged, and they're doing some biotech students, previous biotech students have been engaged actively for production of vaccines, Covaxins and Covishield in India. So we have discussed about the research institute and the top industries where biotechnology students are can get opportunities. Next is central and state government sectors. So central government sectors like forensic laboratory, in each forensic laboratory, the biotechnology students are working, they are making the PCR, DNA fingerprinting, and they are engaged into DNA fingerprinting work to find the culprit or to solve the parentage dispute, like many more. And already you have studied in papers many disputes, parental dispute, murderer case, rape case have been solved through DNA fingerprinting technology. And for this DNA fingerprinting technology, PCR technology is used. And this is the area where only biotechnology students can able to work, can do well, because they are exposed in these areas. What is PCR, what is RT-PCR, what are the electrophoresis, like the immunoblotting, like this. Then different state and central governments, they have running different plant tissue culture and laboratories, and they are also producing, they have the seed corporations. So in that sectors, the students can engage. Then biofertilizer industries and micronutrient agencies run by the central and government. So as you know, the biofertilizer, which is the like by rhizobium, azotospector, azospirillum, azotobacter, azolla. They are nowadays, the government is giving importance to these biofertilizers. They are the nature's gift. You see, these biofertilizers, the rhizobium or azotobacter, azospirillum, they can convert this non-available atmospheric nitrogen to ammonia in their body at 37 degrees centigrade, in the presence of nitrogenous enzymes. But similar reactions, nitrogen and ammonia, hydrogen is converted to ammonia in the fertilizer industry, which requires more than 500 degrees centigrade. So a lot of fuel is required, which causes pollutions, which cost is more. So nowadays, biofertilizer applications in the field is given more importance because it is eco-friendly, it enriches the soil health and also provide nutrients to the plants. Similarly, biopesticides. So we are using some parts of some microorganisms which will kill the insect or kill other harmful pathogens. So these agencies are run by the different central and state government agencies where our students our biotechnology students can get placement. And similar industries, biofertilizer, biopesticide industry are also run by the private sectors. There also our students can get employment with good salary and remunerations. Then fourth is entrepreneurship. This is a very good sector where biotechnology students will get employment and it will give more employment to other students. So this sector is not so much encouraged, but the students should opt for this. In this way, they can get more money, as well as they would give employment to other biotechnology students. So here I shall discuss some of the examples where the persons have adopted this entrepreneurship program and became very rich in few years and provided lot of employment to the biotech students, and other students. Lot of employment. I also give support more to the government. So best example is your the Biocon, which is a Bangalore-based company, which started in 1978 with a budget of only 10,000. This Biocon started as a company selling the enzyme papain. So this papain, the enzyme produced from the papaya. The first they extracted this enzyme. Later on, in the year 1990s, the founder Kiran Majumdar decided to change the focus of the companies from selling enzymes to selling biopharmaceuticals. And subsequently, the Biocon became the topmost industry in the field of biotechnology. Now, it has an annual revenue of 4,709 crores in 2018. So in this way, one person is giving a lot of opportunities to many persons. Many biotechnology students and other students are engaged in here, and they're producing different enzymes. Then insulin also, biotechnology nowadays producing monoclonal antibodies. These monoclonal antibodies used for diagnostic kits, for like your malaria, dengue, or pregnancy test, or even to know whether a plant is a transgenic plant or general plant. So this company is producing nowadays, and that way the second is The second startup is Bharat Biotech. You all know the Bharat Biotech is now establishing a unit in Bhubaneswar. So it is a Hyderabad industry, and it was founded in the 1996 by an Indian scientist, Krishna Ella. One of the leading biopharmaceutical companies in India, Bharat Biotech was the first to develop and patent vaccines for the Zika virus, Zika vac. In the world, they have developed these vaccines for Zika virus. And in this year, emergency approval is given for the vaccines developed by Bharat Biotech. This is the indigenous vaccines using the indigenous technology. And this vaccines was developed by Bharat Biotech and the ICMR, Indian Council of Medical Research. This is the first Indian indigenous vaccines, and its name is Covaxins, which has been developed by this Bharat Biotech with the collaboration with the Indian Council of Medical Research. And it has got approval, emergency approval for use. So in Odisha and throughout the different parts of the country, these two vaccines, Covishield, developed by AstraZeneca and Oxford Institute, and produced by the Serum Institute of India in India, and Covaxins developed by the Bharat Biotech and ICMR are used to our people, to our front warriors of the corona. Another entrepreneur, I shall tell, some students they've developed, that is GA-NIT lab, that is Genomics Applications and Information Technology Lab, GA-NIT lab. And it was founded in the 2010 in Bangalore by Dr. Binaya Panda and Dr. Vijaya Chandru. It is an independent government-funded startup. This lab studies genome related to oral cancer and helps in mapping their genes. It is also involved in creating analytical tools which are effectively analyze and manage large-scale genome data, mainly from genome sequencing of disease or tissues like cancer. This small startup, now they have grown a lot. The another is C6 Energy. This startup was founded in 2010 by 4 IIT Madras graduates and works towards the development of scalable solutions to solve the problem of overconsumption of energy in India. And this startup, they utilize our nature's gift, miracle gift, algae. So algae is known as nature's miracle gift. It has the two capability. It has the nitrogen fixation capability. It will fix the atmospheric nitrogen to ammonia and utilizes it. And it is also a photosynthetic activity. So for its growth, there is no nitrogen requirement. There is no carbon requirement. It can grow well. And it can grow very fast. And that algae can be used. This photosynthetic biomass from algae can be used as fuel. And this startup has patented technology to facilitate large-scale cultivation of selected sea plants.
Thank you, Professor Samal sir. Now I welcome to Dr. Prasad Kumar Das, Principal Scientist, National Institute of Plant Biotechnology, New Delhi, to deliver his vision and his experience to our students. Dr. Das sir.
Okay, so thank you, Mr. Bakshi. Thank you, Dr. Samal. Thanks, Mr. Nayak, who has been patiently waiting. So let me tell about, let me know that all the attendees are from Odisha or they are from other places, so that I can talk sometimes in Odia also.
Any Gujarat student with us? Gujarat? I think Gujarat student.
Okay.
Yes, sir.
Then I will talk in English and Hindi. Let's
Yes, sir. Yes, sir. Yes, sir.
because we are running short of time. 8 o'clock.
Yes, sir. Yes, sir. Yes, sir. We are
So,
not short
so
of time.
let me tell one thing. My first job here would be to inspire all the students to pursue a career in science. Because nowadays, of course, my son is also in college, and I see the trend in the current generation age. They want somehow to get a BTech degree or something like that, and they immediately want to join some company or they have their own startup. But the pleasure of doing science you will not find anywhere, because science is just a means. Our entire objective is for social science. And science, I mean that if you can solve a problem for any pertinent problem of India, so it will be a great satisfaction for you as well as the community. That's what is our objective and my objective. So I did my BSc Agriculture from OUAT in the year 1988 to 92. And then what I did was I did my Masters in Biotechnology, that's Molecular Biology and Biotechnology from IARI. IARI stands for Indian Agricultural Research Institute in Biotechnology. Then I did my PhD from here. Then I went to postdoc to USA. So why am I telling my journey is just to inspire you. Science takes time. It's not shortcut. If you are patient enough and you are ready to invest your time till the age of 28 years, 30 years, you will be a masterpiece in which what you can do is you can think a problem or visualize a problem, try to solve it for the society, and you gain the satisfaction. Dr. Samal has already told so many examples and a concise story of the entire biotechnology journey. But I assume that most of you are in graduation or just completed the graduation. So there are few options that I would like to tell you, because you must, if you want to pursue a career in science, you must at least accomplish your PhD degree. Without that, probably your, celebrity goes down. So you must try to do a master's program, and there are multiple institutes like Dr. Samal has told. IRI is one of the best institutes as far as agricultural biotechnology is concerned. You just walk into the lab. Of course, it has a beautiful campus. You just walk into the lab. You will be given choice. Okay, what kind of research you want to do? First, go and orient yourself. Then you can choose a lab, choose a mentor who will tell you what to do, how to do. They will be doing the hand holding. Literally, they will hold you, because biotechnology, the beauty of biotechnology is it's not kgs or it's not liters. What it is microliters. You have to use a very small, you cannot even weigh 1 ml. It's very difficult, or you cannot measure. But in biotechnology, it is too much. In agronomy, you tell, okay, the fertilizer dose is 60, 80, 60. That is in kgs, in quintals. But biotechnology beauty is it is in few microliters, few micrograms, few nanograms. So for that, you will, the moment you enter into the biotechnology lab, you will be so enthralled that, okay, I have gone to the corridor of science where I can do whatever I want. And then once you have done your MSc, the journey doesn't stop there. You must and you will do the higher degree, that's called the PhD program, doctorate program. And once you have done your doctorate, you have multiple avenues where you can go and join a government service. And there are multiple institutions like one is called CMAP, Lucknow. They also recruit scientists. The pleasure of doing science along with the job profile refers you as a scientist. You think, you pursue your career, you patiently do the work, and then you come out with a result. I will take one example. For example, I will take one success story in plant and one in animal. So in the success story in plant is, the papaya. Papaya is an everyday table food that almost every person in the world consumes it. But it is devastated by another viral disease which is called papaya ring spot. The entire population is eradicated. And so what you do if there is a problem, either the plant or the animal will evolve itself, that is natural evolution. We have all evolved from the small organisms, and then through the process of mutation, that is a sudden change, you evolve, and we have, the human beings are evolved. Similarly, the choice before the plant is either it has to evolve so that it can, take care of the papaya virus. That's one. Or something has to be done artificially. Some genetic intervention has to be done. That is what is referred as genetic modification. And the crops are referred as genetically modified crops, genetically modified organisms. In this, what you do is you take some gene from outside source, put it into a plant and make it resistant. And in the papaya case, what happens? Since it is caused by a virus, viral disease, so the virus will come like any virus affects human beings. It will first invade through the skin or through the nasal intervention, and then it will go infect our body. So the first step the virus attacks the plant is it will go, and there is a very unique process called replication. It replicates and it makes a lot of virus particles. One virus infecting one cell, then it produces multiple viral particles, and then it comes out. Then it invades the next cell, and that is how it infects the disease. Okay, so what the plant genetic engineers they did was, since there was no resistant source known, they thought, is it possible that we can stop the replication of the virus in the plant itself? For that, what they did was they took a protein which is called replicase protein gene. And so what they did, they used that gene and put it into the papaya by a simple technique which is called tissue culture. I mean, you must have known the tissue culture is a method in which you can generate a plant from a small tissue, maybe a leaf tissue, maybe a root tissue, maybe a stem tissue, and you generate a plant. It's a very standardized protocol or a procedure in which you develop a plant. The process is called organogenesis. Keep it in mind, the word organogenesis, if you can Google it, you will find it out what. So through that, they put the replicase gene into the papaya plant, and now the papaya plant, which earlier did not have a replicase gene, is having an external gene, the gene which was not present in the plant community. So the moment the virus goes and starts replicating, this viral protein, it comes and encapsulates, means it covers it. So what happens? The virus cannot, ramify, it cannot expand. So that is how they gave a complete cure to the papaya, and first time it was done in USA, Hawaii. Okay. Another failure case, which is also very important. All of you know, if you are a student of agriculture or even otherwise also, you know, there is a disease called foot and mouth disease. Foot and mouth disease called FMD. It is a very, very precarious problem in case of the cattle, the cow and the buffalo. What they have, this is again caused by virus. I mean, when I was a student, I came to know this is an important disease of the foot and of the cattle. So, but still now the vaccines are not available. It's very sporadic. It's not rampant like our Covaxin and Covishield, but it is a very difficult, painful death of the cattle. The cattle will start, it cannot walk because as the name says, foot is infected, so it cannot walk and then it cannot stand, so it has to lie down. And then the mouth starts, it cannot eat because the mouth is infected, it starts bleeding from the mouth. You can imagine how painful the death is. And if we can, as a scientific community, devise a cure for that, cure means complete cure. And the entire cattle population will be saved. It is not available. The third one I will give, that is called the polio. All of you might have seen, not polio, let me take the example of smallpox. Smallpox is another peculiar problem which affects human beings. You have seen, probably you might have been seeing nowadays. When we were kids, we used to see people who have all that smallpox infection, the marks on the face and the body. And it was a devastating, it was very killer. Of course, as a scientific community, people worked years and years and they found out, as Dr. Samal said, the attenuated virus, the same smallpox virus, but it is disarmed, it is attenuated. So once it is attenuated, so that is called attenuation, means it is a defective virus, it cannot cause the disease. So you take, so that virus was fed, I mean it was injected into the human beings so that your body responds, so something foreign has come. So it starts developing an antibody. So your body is ready, even if you have a viral infection of smallpox, you will not be, I mean the disease will not be there. So 3 examples I have taken, okay. 3 examples I have taken. I have some more time. So why we need this biotechnology? Is it really needed? If traditionally we can do, traditionally rice was a weed. You must have seen the weed rice varieties which grows in swampy areas. It doesn't yield much. There is no yield. कोई उसमें yield नहीं आता है, कोई उसको खाता नहीं है, कोई taste नहीं है, कुछ नहीं है. You cannot harvest also. The moment you go and touch it, it falls down. But rice, that weed rice became, through mutation or through spontaneous mutation, natural evolution, it became a rice variety that we have used. But that process of evolution is very, very low, and the yield, the agricultural yield that we get, on an average per year, the yield through normal traditional agriculture is only 1%. Keep it in mind, I will repeat it. Only 1% increase as far as normal traditional agriculture or whatever you do. And what is the growth of the population of India at least? It is 1.92%. Per year, we are increasing at 2% rate. Just hold on 1 minute. There's an important call coming. हाँ कितने मीटिंग है? हाँ बोलो. हाँ मैं हाँ. तो घर पे तो मैं बोल दूँगा मैं मीटिंग में हूँ. Thank you. Sorry. Where was I? I was talking the genetic yield advancement through normal traditional agriculture, but our population growth is 2% per year. So do you think the way our population is increasing, the way our production is increasing, it is not commensurate? At some point of time, we have to produce more, and the population has to be at least at par. So eventually, we'll run out of food grains. We'll have crisis. The hunger will set in. The hidden hunger will set in, and then it will become chaos. So ultimately, our objective is the yield increase in case of any crop. Cattle ले लो, आप poultry ले लो, आप कुछ भी ले लो. It doesn't matter what it is. The productivity has to be increased, and it has to be at par or commensurate with the population increase. And that is not possible through traditional agriculture. Mark my words. Take this as a gold standard. It is not possible. So if not possible, how to feed the population? We have to have genetic intervention, which is called genetic engineering. We have to engineer the plant. For example, let us take rice. Rice will produce 150 to 180, 200 grams per panicle. Rice produces panicles, so per panicle we will have 180 grams. Is it possible that we can increase it to 400 grams? The answer is yes. The answer is the process of mutation. In fact, the plant genetic engineers, they have taken that mutation and put it in the normal traditional variety, and it produces 412 grains. I am not making it up. It's fact. If you are interested, you know what is science. Kindly go to a paper published in the journal Science in 2005. That is called how you can change the hormone homeostasis of the plant so that it can increase the number of grains. 412 grains. It is possible. It is doable. People have done it. Now we have to do it in a large scale. For that, we need plant genetic engineers, molecular biologists, plant physiologists, biochemists. Another example which Dr. Samal has told, and I will just a little bit elaborate on that, and then I will stop. The vitamin A content in rice. For the developing countries, what biotechnology can do? Biotechnology can do the vitamin content in case of the people who are in Africa, who are in India, who are in Southeast Asia, the developing countries, their main staple food is rice. So is it possible that, because vitamin A is a very important hormone which is required for the overall growth of the human beings, and it is expensive. Is it possible that we can enrich the vitamin A content of rice so that anyway we are consuming it and that will be consumed? And the answer is yes, scientists have done it. They have taken a gene from a potato and from a plant, that's bougainvillea. And they have put both the genes and they have made it, what is it called? The rice which is named as called golden rice. You can, everybody is having access to internet, you can just Google it, golden rice. You will find out the entire pathway is engineered in rice. The entire pathway is engineered in rice, in which you have the production, higher production of vitamin, provitamin, basically, and then it gets processed to the vitamin A. And since it is a staple food product, I mean, we can use it. So this is another successful stories. Okay. The third, and one more example let me take, that is called tomato. In tomato, we have a variety which was naturally not present. It was genetically engineered. It's referred as flavor saver. As the name suggests, the thing is that the ripening of the tomato, because tomato, you see, it's a green tomato, then it becomes red tomato, then the tissue degenerates and it's rotten. If a normal tomato ripens and stays for 12 days, a genetically engineered tomato, it can stay for 35 days. Scientists have produced it. They have demonstrated it. And how they did it? Because there is an enzyme called polygalacturonase, which actually degrades the cell wall of tomato, and with ripening it starts. So what the scientists did, they told, okay, this is the notorious enzyme. So can we just make it defective? No more enzyme. The polygalacturonase is not produced. So the ripening will be happening because ethylene will take over, but it will take more time to completely degenerate. 35 days, imagine. And imagine when the tomato is produced, you must have seen and you must have read in the newspaper, 1 rupee kilo tomato. Farmers, they are so disgusted that they throw in the road because your transportation cost, your production cost, they are not going to down. But your market value is 1 rupee. They will not get any remuneration. They just destroy it. But if they can make it staggered, okay, now one tomato peak season, but I will plant it in such a way that my tomato will stay maybe 30 days, 40 days beyond the normal peak harvest. So he can have a premium on this. So there are multiple examples, there are multiple problems. So my advice to all of you would be, pursue a career in science. It is rewarding. It will give satisfaction. Of course, it takes time. You cannot hurry up. If you pursue, if you are ready to devote yourself for the cause of science, there are innumerable problems. For example, I will take another example. Tungro virus infection in rice. No cure. The entire field gets devastated. Brown plant hopper, another, it gives a feeling of the entire field is burnt. Then there is another fold called cucumber mosaic virus. The entire chili plantation is wiped out. We are still searching for the answer. We do not have the answer. We still have to get it. Can we do it? Can we commit to ourselves? If we can, why not to pursue a career? There are multiple. If you are good, if you are passionate, and if you can devote time, you don't have to worry for the future. Biotechnology is the answer. And there are multiple institutes. You become a graduate, there are multiple fellowship avenues. The organization called CSIR, you can write the exam and they will give you fellowship. You don't, once you become a graduate, probably you will feel like, okay, let me be independent because I should not be dependent on my parents. You write fellowship. Our ICAR, Indian Council of Agricultural Research, that also conducts exams and it gives fellowship. Take the fellowship. It's a very good handsome amount. You go to any college, you do your master's degree, you write exams, get into the PhD programs. There are multiple exams you can go outside the country to do the postdoctorate. Or you can pursue your PhD in the different countries. You can go to USA, you can go to UK. I will just name some of the fellowships like Humboldt Fellowship, Boys Cast Fellowship, DST. DST is the Department of Science and Technology, Overseas Fellowship. All of you can apply. All of you can compete and get it. But you have to be good. You have to be dedicated. And you have to be deeply focused. So probably it's already 20 minutes. So I will just wrap it up with one example. There is an agency called NTA. All of you know. Just you can search it out. National.
Sir, audio missing, sir. Dr. Das, audio is missing. Audio is missing. Audio, sir. Audio. Yes.
Mute. Yeah, is it okay now?
Yes. Okay.
So what I was telling is the last bit is how will you pursue, because all higher studies, they cost money. You cannot be dependent on your parents. So what you can do is there are multiple fellowship agencies. That's again by Government of India. So you can write that, you can pursue your master's program, you can pursue your PhD program, and you can pursue your postdoctorate program, postdoctorate program, and then, then you can come back and do your research. There are multiple institutes. There is no dearth. Only thing is you have to be deeply focused. And probably if you would like to get, I don't have time, but what I can say is if you are interested, you can go to our website that is called nrcpb.res.in. You will see my profile and you can send me a mail. I will be happy to answer your questions. I think I would stop here. Let the other speakers speak.
Thank you, Dr. Das, with us. Before going to welcome Sagar Nayak, one of the eminent biotechnologists with us, Director NIPB, Dr. Ajit Kumar Sasani. Can you spare a 2-minute talk with, interact with the students, sir? Dr. Sasani, sir, the most emerging ODI scientist who reached the top in India, Dr. Ajit Kumar Sasani. Dr. Sasani, sir. Hello.
Yes, yes.
Yes, sir.
Hello.
Please, yes, sir. 1 or 2 minutes, sir. At least you can spare your journey at least 2 minutes within 2 minutes, sir.
Actually, I will appreciate one of my scientists, senior scientists, that Prasad has already told everything about biotechnology. Also, Kailash is there. He might have told, described how you can be a biotechnologist. So about my journey, I am from Redakol, Sambalpur. Odia College chalibo ta?
Yes, sir. Yes, sir. Yes, sir.
Redakol, Sambalpur. I traveled NIPB. I have done my PhD. Then after moving around CSIR lab, then I came back to NIPB again. And there are bright scientists in NIPB, just like Prasad. Already he has told you many things. So you pursue your dream, you will be there. So do you want to say me anything, any other thing? Already Prasad has told. Okay?
Yes, sir. Yes, sir. Yes, sir. Thank you, sir.
Thank you.
Thank you, Dr. Sasani, sir. Now I welcome to Sagar Nayak, Senior Research Fellowship from CSIR-NBRI, Lucknow. Yes, sir. Here, audio, sir. Audio.
Okay. Am I audible now, sir?
Yes.
Okay. Thank you, Mr. Bakshi, and thank you for providing me the opportunity to share the knowledge regarding the topic of discussion today with all the attendees present over here. And I'm also excited to interact with the students who are aspiring to be a biotechnologist. And as Dr. Kailash and Dr. Prashant explained very beautifully regarding the biotechnology, how it started and how it evolved, and what the biotechnology has given to the entire mankind through beautiful stories. Both the scientists explained in a very beautiful manner, and as Dr. Prashant insisted all the students to take up research as their career. And being a research student, I would also recommend all the students who are participating this webinar to take research as their career. However, people have their own priorities. You can, apart from going to research field, you can also go for entrepreneurship, or you can pursue a career in teaching, or you can offer some companies, some biotechnological companies. Okay. I think I don't have much to say regarding the biotechnology, the boons and the benefits that biotechnology has given to the entire science fraternity and the mankind. Rather, I would like to focus on the exact procedure, how the students can get entry into different biotechnological courses provided by various institutes across the India. So let's begin with the students who are in their high school and aspiring to be a biotechnologist in near future. So if you are in high school and willing to take science as your stream in intermediate, then I would suggest that you should take biology as one of your subjects. And recently, some of the institutes in various states have started biotechnology as one of the subjects to take from in the intermediate level. You can also opt for biotechnology as one of your subjects in intermediate college. Then you can simply go for biology, as biology opens after you complete your intermediate. After successful get options to choose from. You have the first option that is available with you is to go for engineering in biotechnology. Various topmost institute Guwahati BTech in BE Bachelor's of Engineering degree in biotechnology. Apart from IITs, you can also opt for NITs like NIT Rourkela, Warangal, and Calicut. These are the NITs
Audio is missing. Sagarji, audio is missing. Audio. I think network problem. I think network problem with us. Sagarji. Hello.
Okay. Actually, there is some network issues. Am I audible now? Is it?
Yes.
Okay.
Right today. Yes.
Okay, thank you. Actually, network issue right before. Okay. Now we have IIT and a student must have a very good rank in IIT JE, and also some of the technical state universities and deemed private university providing look for those colleges as well. And the second option, which is available for the students who have recently completed their intermediate degree, they can go for BSc Biotechnology, which is offered by various state and central universities, and there.
Hello. Sagarji, not audible.
And forward to. Okay. Am I audible now?
Yes.
Yes. Yes, sir. Okay. Okay, sir. Actually, there were some network issues. I think I'm audible from now onwards. Yes, sir. I'm audible now.
Yes.
Okay. Okay, I will repeat what I exactly said right now. I was talking about diploma in biotechnology. A, if a student is willing to her a biotechnology degree within short duration of time, like 1 year or 2 year, they can go for diploma in biotechnology, which is provided by various universities across India, like University of Mumbai and Patna University as well. And these are the bachelor's degree in biotechnology, which are provided by various institutes all across the India. Then if you have completed your BTech degree, then you can go for MTech, or you can also go for MSc. If you have completed your BSc degree in biotechnology, you can also go for MSc in biotechnology. And after successfully completing either your BTech degree or your BSc degree in biotechnology, then we are open to various other options available at the master's level. If a person is not willing to further proceed his or her career in biotechnology, he or she can start entrepreneurship or can go for any company also. And let us talk about various master courses in biotechnology that are provided by good institutes in India. Okay, then starting from the IITs, which are regarded as the top most institutes and universities that are present across the India. There is an exam known as IIT JAM. for the students, I would like to repeat it. This is known as IIT JAM, that stands for Indian Institute of Technology Joint Admission Test for MSc. This is the examination that is a joint venture of all the IITs and Indian Institute of Science. IITs and Indian Institute of Science um, combinedly conduct this examination every year, and also other institutes like Indian Institute of Science and Educational Research (ISER) and National Institute of Science and Educational Research (NISER). They too participate in these examinations. So we have IITs, ISERs, NISERs, IISc, which are providing master's degree in biotechnology, and what you have to do, you have to just write the IIT JAM exam and you have to crack it. Then if you are willing to pursue a career in joint master and PhD degree, which is of 5 years of duration, you can also try for this IIT JAM examination, where the IITs and IISc and ISERs and NISERs are also providing a joint degree of masters and PhD. Okay. Then coming to the universities, some good universities which are giving MSc, MSc in biotechnology. Among those are central universities that are distributed across India. They are conducting a single common entrance test known as CUCET, that stands for Central University Common Entrance Test. The students, after completing their bachelor's degree, they can write this exam, and once they crack, they can get admission into these top central universities. Apart from IIT JAM and CUCT, we have another examination known as CEEB, which stands for Common Entrance Examination for Biotechnology. This is an examination conducted by JNU in association with some more universities. I think their number is around 50 to 60. 50 to 60 number of universities participate in this examination known as Common Entrance Examination for Biotechnology, and the organizing body is JNU. And here also the students can give themselves a shot that they can try this examination, and if they crack this examination, they can get a chance to pursue their career in biotechnology in
Audio problem again. Sagar ji, again audio problem is there. Hello. Hello. I think. Hello. Hello, Sagar ji. Okay.
and the
I think network problem with you, so we are unable to hear your voice. Sagar ji, Nayak ji. Hello.
okay, again there was an interruption due
Okay.
to bad network connection.
I think we will take the questionnaire session at the last session of the evening. So I think that will be better. So anybody have a question, my dear student? Those who are joined with us, any question with us? So we'll discuss.
Yes, I was talking about. Okay. I think I'm back.
Yes. There is a bad network with you. Hopefully, we'll start the questionnaire session. Anybody have a question related to biotechnology, dear student? Hello. Hello.
Yes,
No
actually there is a lot of sir, there is a lot of internet issues. So let's see.
Yes. There is an issue, sir. Student, any question with you, my dear student, Rakhi, Moili, Sagar, Ria, Bandita.
Yes, sir. Network issues, sir. Due to network issues, कनेक्शन बार बार कट रहा है.
यस सर, यस सर. कोई किसी का सवाल है बच्चे लोग का? राजलक्ष्मी जी, वंदिता.
Sir, with the other panelists, with the other scientists.
यस यस यस.
Yes, sir.
सवाल किसी का है तो? नहीं तो हम सेशन को यही खत्म कर लेते हैं, क्योंकि काफी समय भी बीत चुका है. हम 17 मिनट बाद देरी में चल रहे हैं. हेलो बच्चे लोग, एनी हैव क्वेश्चन? I think we'll wind up the session, sir, because hello, Samal sir, we'll wind up the session. Thank you very much being with us from NBRI Lucknow, Sagar Nayak ji, Dr. Prashant Kumar Das ji, and Dr. Professor Samal ji from OUAT. Thank you very much, because due to bad weather.
धन्यवाद.
हाँ ये सर, थैंक यू. आपण माने स्टूडेंट मान ये भाई कार्यक्रम आगे को भी जारी रहिबो. आमे तो पुणी दिशा प्रोग्राम करूछु, प्रति साइंटिस्ट को लेकर इंडिविजुअल टॉक शो करूछु. तो आमे निश्चित भावे विज्ञान को आगे को नवा पई आपण मानकर प्रेरणा निश्चित भावे हमर छात्र छात्री को सहायक हबो. आज कार्यक्रम को एठी रखिबा, पुणी आउथरे देखाबा एवं आसंता शनिवार ठीक एक समय. थैंक यू. नमस्कार. थैंक यू. थैंक यू सर. थैंक यू. गुड नाइट.